You're live.
And we're live. Welcome to Child Lunch. Everybody, welcome. This week, we come to you with a word from Paul Schreiner. Third-party web services to scale is what we're going to be talking about today. Some good stuff. If you didn't RSVP, get on Meetup/ShotDevs, register so we can get a count for how much pizza. Pizza is important. Meetups, they're all here. These links are clickable. You can visit these slides at chawdev.com/lunch-slides, and then you can click on these groups and you can find out more about them. If there isn't a meetup that meets your needs, come to us. We have resources. We can help you set that community up and get things going. You can get involved with us on GitHub, on our org, or on our Freenode channel, ChawDev. As mentioned before, there's our slides. Job board. We're going to be doing this thing came about because we had a lot of people in the community asking about jobs and like organizations asking about how can they get the word out about jobs they have open. So we created this job board to that end. So you can go here and check out what's going on. We're going to do, is it every second Thursday, we said? Every second Thursday of the month, we do like a stand-up thing where if you're looking for work, you can kind of get up and pitch yourself. And then we also let some of our sponsors come in to talk about some positions they might have open. And it's just a really quick, 5-minute thing. So you gotta look out for that. You can also submit jobs on here. So there's that. Our partners, we gotta give a shout out. These are the people that provide you with the space and also the pizza, which is lovely. Shout out to all the sponsors here. This next thing, tweet to a sponsor. This is kind of the only way that the sponsors know that, hey, their money and stuff is true. Doing good stuff in the community. Give them a thanks. This is our featured sponsor today, so give them a shout out. Chat Tech. Get on Twitter. Let's vote. Everybody, get your phones out. Go to get.io/vote. This is a good chance because once you get on here and you vote for how lunch was today, then you can go immediately from there over your Twitter app and give a shout out to Chat Tech. It's so easy. Thank you. Thank you. It's so easy. Just go one thing over to the other, and then everybody gets really excited and happy. All right, we got somebody out there who's getting tired of Mr. T's. All right, fair enough. All right, well, without further ado, Paul, I'm going to kick it off to you. Good.
This is really important, by the way. Just so you know.
Super important.
There we go.
You know I need it.
There we go. Excellent. Maybe. Excellent.
Very good.
We'll see. Let me put this water glass down. It's great to be here. Thanks for having me. The thing is about web services is it's not... here's the thing. I get super excited about it, but I'm probably the only person in the room who's like, dude, web services. I litter it with sarcastic things like mandatory cliche business clip art. No, we did great. Good job. So anyway, I'm pretty comfortable with interruption. I know that this is more of a presentation forum, but if there is a question, I'm happy to address it as we go. There's contact info if you want to get a hold of me. Other things, I thought, let's build a rapport with the audience. That's the first plan. It's magic. It's working! This is amazing! So I have 5 kids, a little bit crazy. We moved from Washington, a small town in Washington, about 4 months ago. And I've done a ton of web service integration. So when Brett and I were talking, it started with sort of very narrow, and we kind of went, let's drill out a little bit. In all of these presentations, it seems like there's an animated GIF in each one, so I thought I'd get mine out of the way first. So there you go. What is a web service? I thought there's going to be probably a whole range of everyone from I've never seen this, the word web service sounds cool, all the way to I'm thinking about naming my next child something about web services. So I thought I'd start narrow and kind of broaden it out again as we go, or broaden and work our way down. So anyway, what is it? It's a pipeline for communication, for two servers to talk to each other. It's a means to integrate two services, right? I want to pull in the tweets. This is a great example. I was at a conference last week, and I was sitting in a presentation, and we work in the email space, Audience Point does, and in this email, there's real-time imagery so that you can absolutely tailor your content so that the image is dynamic and real based on when you open, such that if you're in New York City when you open the email, it has a map of New York City, right, as opposed to static content in an email. So the person who's up on stage pitching goes, we can put a Twitter feed in your email. And I think this is a terrible idea, right? Because I'm going to blast that Twitter feed if you're on the other team, right? Like I'm going to throw in all kinds of stuff. Potty words, we'll see if those get through, embarrassing things, all kinds of stuff. Don't put those in your email, people, right? As a dynamic feed. It's a terrible idea. It's a great concept, maybe a bad implementation on that particular concept. But it's the idea of integrating two things, right? And it's often, we use the word API. That used to be sort of dedicated to just sort of, here's how you access my application. Now we kind of throw that word in with web services. It's also a gateway to SaaS. SaaS is a stupid term. I mean, it's technology. We just love coming up with acronyms and terms, don't we? SaaS is one of those, software as a service. Exact Target, Salesforce Marketing Cloud, Salesforce. I mean, there's so many of those that we can just go on and on and on, but they all have APIs. They all have a gateway in. Where can we use it? Where can I use it? The idea was, when I was writing this would be personalized to you. So when you read it, you could say, where could I use it? Although when I read it, it sounds like I'm just kind of self-centered. I get that. That's okay. Where can you use it? Google Maps is an easy one. Yahoo Maps, I did an implementation for Yahoo Maps with Adobe. This is like 5-6 years ago, where you took the picture, the photo was geocoded with where the photo was taken. So I read that out of the photo file and dropped it on Yahoo Maps, which sounds like a pretty simple implementation, and it kind of was, but I ended up having Yahoo Maps source code on my computer, and we'll look at that here in a little bit. But social, Twitter, Facebook, all of those, they all want you to integrate. They all want to pull content. Everyone wants to be the content source. Mobile, user tracking, data exchange, automation and workflows, being able to pull data in from disparate systems into yours so that you can have a much more relevant experience for your users. Okay, how do I get started? So, and this is, again, I figured there's probably from the vanilla brand new all the way up to I'm in it to win it. Google brand, so exact target, Twitter, whatever, and I practiced a couple times. I was like, oh yeah, that's the way. Anyway, just getting started. Everyone's got a getting started link. Here's our API, boom, right? That gets you started. Get all available documentations. Now we're getting into the nuts and bolts of it. Get all available documentation, everything. I mean, be greedy about getting documentation, everything. So in the case when I was working with Adobe, I was like, can I get Yahoo Maps? So I got I didn't just get their API, but I got the actual application. It was in Flash, so it was ActionScript, but whatever. Point is, I didn't have to ask them questions. There's sort of the documented features, and then there's the undocumented features within APIs. And so anything that you can get will help you in the long run. So the first thing you want to do is read it, get to know it, like memorize it, that kind of stuff. We're nerds. This is what we do. We memorize things. We don't want to memorize it, but it gets stuck in our head forever, right? I remember that my junior high locker combination, 7th grade, was 28-32. Why do I remember that? I don't know, because it's how our brains are wired, right? Junior high, 7th grade, PE locker combination, 3915. Come on. So read it, learn it, like it gets stuck in our brain so that we can have fast access to it, right? We also want to identify all sort of available metaphors and verbs. We want to know, is this going to work for us? The idea here is we want to We want to figure out early. No, that's in the wrong order. Don't trust the API. I'll come back up. Don't trust the APIs that you're working with. We want to identify all kinds of metaphors, verbs, everything, because the reality is it's probably not going to work. There's what we call undocumented features or bugs. So we want to verify method names. Do they actually work? Write a proof of concept app early, inch wide, mile deep. We want to confirm the return structure, identify all error codes ahead of time. What am I going to deal with? Because the reality is people build their web services layer kind of last. It's kind of the add-on. They focus, and if you guys are on the enterprise sort of coding side, you know what I'm talking about. You're like, let me get this product, this feature to ship. As soon as it's shipped, now we're golden. And then there's that tack on, oh yeah, web services. Crap, we got to support that one too. That's just the way it fits. And so we never ever get this perfect web services. Now it's getting better because we have these sort of service stack and Ruby, different models to do it, but it's still the kind of things that we want to make sure that we understand everything ahead of time. We want to get metaphors, verbs, we want to get return values, we want it all. Next thing is you're going to come to the site and it's going to say, would you like to use our REST service or our web or our SOAP-based service? Again, I came assuming that some may know, some may not. REST is it's kind of a port 80. It's kind of like a regular standard web call, right? It follows the philosophy of an open web. It's really easy to test because it tests in the browser. We can get multiple return formats. It's dirt simple is what I love about it, and it's easy to debug. You got a problem with your web service or with the call you're making, you just pull it up in the browser and you go, oh, there it is. On the other hand, SOAP is XML based. It's going to be a lot bigger. Your payload is going to be bigger because you've got a whole bunch of extra characters in it. It also requires kind of a SOAP scaffolding. You can make a straight XML post, but man, it's a pain in the neck. No one does that. So we've got this additional kind of scaffolding hierarchy stuff that just sits on top of the SOAP to make it work. Now, the upside to that is we can do a little bit more with it in terms of security and ports, and that it's kind of the standard that came out initially. And because it was so complicated, REST, why can't we just use the browser? Okay, that makes sense. Debugging is harder, but because of the additional security, because we can this is stateless, this is stateful, right? So in a stateless post, you're going to make sure that every single REST call has everything it needs on the call to be successful, right? Versus SOAP, you can kind of keep things in session. So again, this is just kind of a diagram looking at it. I know, it's that classic thing. If you put something on the screen, make sure that no one in the front row can read it. I don't care that you can read this. This is about, again, building rapport. No, not really. REST, the idea is this is simple. REST is this. Your browser makes a call to a server and returns it back. It's a port 80 REST call. It's like saying www.chawdev.com, right? Versus SOAP, we've got WSDL layers, and we've got sort of verification and validation that the data coming in and out is correct. So from again, if I'm a banking institution, I'm probably going to fall on the side of making sure this is all SOAP-based. If I'm everyone else in the world, I'll probably use REST, because REST is awesome. Now, my instinct, I always favor REST, because it's easier, both in terms of what we build, but also what we consume. Given a choice, REST is fantastic. It's a representational state transfer. No one knows that. Point is, you're just going to get started faster. That's what we want. And then we already talked about this a little bit. Don't trust the API that we're working with. Verify, verify, verify. Assume everything's going to break. The problem is, we talked about sort of last minute things. Many error codes aren't documented in web services when you're working with them. So you go, well, what's the return value going to be back? And here's my different error codes. So identify those early. It's not the priority of the provider to either document those or to even document. No one knows them. And missing error codes can break your integration, right? If you don't know what's coming on, and this was a great one. This is a return code on an email. We work with email, so I see a lot of that. But this return code came back, and this is a great example. This is what we'd call an undocumented error code, right? Sender address rejected. Mail from sender-domain.com, espdomain.com, is blocked for spamming spam traps. Stop accepting spammers as clients. That's real world. Like, that's in the wild. Fun. Write a proof of concept application. First thing, before you dig in on an implementation, make sure everything will work. Assume that what you're doing is going to break, and it's probably not your fault. You're wonderful people. You didn't break this. You didn't create the problem. But assume it's not going to work. So prove that it's going to work. And it's because it's better to fail early than get all the way down to the very end and go, oh, crap. I mean, we had this with a provider. All of their documentation said, so we integrate, we send emails in. We send emails into ESPs to actually do the delivery. We say, here's the best time to send it, and then the ESP email service provider actually deploys them out. It's what we want. That's really good. So this particular ESP, they had everything documented, and it looked like this is going to be awesome. This is going to be a quick implementation. The problem was, not everything was documented. It didn't work. We actually couldn't deploy the emails to them. You are an email service provider, and it didn't work. Man, I wish that we had done this on this one. Even though it may take a little bit of extra time, assume it's not going to work, prove that it will. And we want that to be like an inch wide but a mile deep. Like, let's test every piece out all the way down to the error codes and feedback loop. This one, identify a technical resource. I know it sounds stupid because it's like these are web services. What I've found is when we're talking about any major thing, actually anyone we're working with, they always have someone that's like the developer evangelist. Great. That person is there to take care of you. Find them. It's well worth your energy when your boss comes to you and says, you've got to build an implementation into Yammer. What's Yammer? Didn't they get bought by Microsoft? They did. That's going to be awesome. So anyway, identify a guide, someone that can walk you through it. There are secret handshakes. There are undocumented features. We run into this all the time with our good friends at ExactTarget, and I will never speak ill of our good friends in Orange and Blue, but because they put a lot of food on our table. But there's things that just, they're kind of middle of the night, let's just slip that into the build and no one knows about it. And then when we run into it, it just crushes our timelines. So that's where having that guide, that person that we can call on the phone and say, what's going on? And I don't mean technical support, because they're going to say, oh, yeah, we'll give you our technical support people. You will be on the phone for 8 hours and get nowhere. When you get their home phone number, their cell phone number, whatever it takes, find them, get whatever leverage you need on top of them. You know what I'm talking about. Anyway, it's the last piece that people do, even when it's a part of the architecture. Like even what's baked in, and we're a services-driven implementation, so we're consuming our own web services. They're still at the last minute going, well, if I'm actually a user, how am I going to use this? So find a guide that's going to pay off. To scale, oh goodness, this is the one, I think, this is the one that beat us down so many times. Web services are a single call, right? You say, hey, go get this user, return it back. Go get this user, return it back. So the initial plan was, okay, well, we will just parallelize this, right? So we're gonna multi-thread the thing, and instead of having a single call saying get user, we're gonna have 100 concurrent calls saying get user. And then we realized we're going to hit some server limits when you're dealing with, big plays. The thing is, even when we get down to like the get list of users, now we get paging implemented, right? So it says, here's 1 through 25, here's 26 through 50, here's 51 through 75. In theory, this is a great plan, but if you're dealing with huge volumes of data, it's not going to work very well. It works very well if you need to say, I'm going to pass you a username and I want to get their vanity name, the display name. Perfect. Absolutely. If you need to update 24 million records, pack a lunch, right? So a single call is fast, but when we bring a whole bunch of single calls together, it becomes really, really slow. So that, then the idea is we'll get all IDs up front so that now we can just kind of chunk that through. So we did that with our good friends at ExactTarget. And we were using multi-threaded API calls. And ExactTarget has got a lot of servers, and we could spin up lots of instances to hit their servers, but we were hitting a threshold on what they would allow through. So we were doing like a 22 million subscriber campaign, and it was taking 22 hours to import. holy crap, right? Versus batch operations, right? Where we upload a CSV file and just import it, right? That sped things. I mean, it changed our business. It made it so that we could now scale in the way that we needed to scale to be able to handle the size of customer that we're dealing with. So batch operations, I know it feels like we're going backwards, but what ends up happening is you upload the CSV file, and it's an asynchronous thing, so you wait until it's all done, you get your finish, and then you say, run import definition, or run extract. Either way, it doesn't matter. The point is, it's way, way, way faster. And I've seen this happen enough times over and over again that anytime you can see the word batch in anything, that means we as the provider know that we suck at enterprise, like big stuff. So we're going to provide you this alternative way in. And if you've got a lot of stuff that you've got to do, use batch. Use batch files, use batch files, use batch files. Because we need to assume APIs or calls are going to fail. Why? Because we're dealing with the internet, the wild. Maybe their server goes down. We had ExactTarget go down for a whole week. And if customers are coming to us, they're saying, your system's not working. And we're like, it's not us, right? But building that in, the retry logic, if at first you don't succeed, back off exponentially, right? Assume API calls are going to fail. So we need to build retry logic into it, right? And we need to build that retry logic in so it continues to hit it, but it shouldn't be every second or every millisecond because then you're just going to get frustrated and so will they. So we want to set a threshold. This is going to retry 5 times, 10 times, whatever is the right appropriate value for you. But you should also have an exponential back off, right? So if the first time you retry is 5 seconds, then 10, then 20, 20, 40, 70, 80, whatever, right? We want that to increase in length so that every time we hit, we're not just making it more painful. It's going to make your operations take longer. But now we're not failing, right? We don't actually fail until this is actually failed, until we get a code back that says this is a fail. Or we've retried enough times that it won't work. And that's when you want to fail big, right? When you've retried it X number of times and you can document that, now we can go to them and we say, look, I hit your web service 25 times over a period of 45 minutes. And it never worked. Here's my packets that I'm sending back and forth. So fail big. And that's where we want to create a strong feedback loop, right? Because if we do fail something, we want to be able to document everything. Because the first thing that the provider is going to ask for is, can you provide me the SOAP envelope? What parameters were passed in on the REST call? Can you provide us the request and the reply? I didn't know you were going to fail. So that's where we got, once we get that kind of failing stuff, we want to capture it right then. So we want to know how it broke, but we also want to hear, building in, when you're dealing with third-party web services, because for me, like, this is my career on the line if this doesn't work. So I want to bake in that, like, let's blow this thing up right now, early and often. So how does it work? Email, GitHub, user feedback, like within the application, SMS messages, whatever it takes, getting that in front of the people that need to know quickly. And then the other thing is using unit tests, right? Good old third-party web service providers. They like to change things. Now, they're getting better. We're seeing versions come out and that. But even so, there was a time when we were doing work with Facebook, and we needed to have a dedicated resource to it because they just change things that often. They tend to change silently without telling you. All of a sudden, your stuff just stops working. And you have those WTF moments where you're like, holy crap. I don't know why this didn't work. Let me check all my parameters. Let me check everything. And all of a sudden, you realize, this isn't me. I didn't do this. So write unit tests and run them often, right? So that we can quickly, again, identify here's where it's breaking and here's why, so you can make that call to say, hey guys, you suck. Which feels like it's going to feel good, but it doesn't. It just takes the pain away. Use your technical resource. The ones we talked about earlier. Suck up to them. Send them thank you notes. Send them stuff. I don't care what it is, right? They're not getting paid enough to deal with me on a daily basis. So how can I help that? But do get your questions answered, right? So it's this relationship where you want to suck up enough that you can get what you want. So get what you want and don't feel bad about it. Their job oftentimes is the developer evangelist, right? They're there to help you get what you want done. The fact that they're overwhelmed and overburdened doesn't change the fact that that's still their job. It also doesn't change the fact that if we approach this gently, we can probably get a lot more support than we could the first time. But they're our gateway to real help because they have access to the product managers, the platform programmers, and sometimes even money to help solve some of this stuff. We ran into, with ExactTarget, and I use them a lot because we do a lot with our good friends at ExactTarget. There's an implementation we did with ExactTarget with a big customer, huge customer. And there's this thing called Audience Builder, which allows you to build out, here's who's going to get this email that's going to be delivered. And so what would happen was they would output it to their data template. And the problem was this data template was not documented. It was one of those middle of the night features, right? It was broken, and we could prove that it was broken over and over again, but it didn't matter because the people at that tech support group couldn't help us. But when we got our technical resource on the phone and we convinced him it was broken, he got us to the product manager. He got us to the guy that wrote the application. And he goes, "Oh, I remember that. Middle of the night push. Sorry." So then he gave us access to his account to fix it. Right? So that was like fantastic, having access to the programmers. All of that stuff comes through this person. Now their job is to prevent you from getting through. So again, it's that balance and that dance. And then the other thing that I'd encourage, what I like, is having them actually do a code review with you. Now if it's not too big, going, hey, here's what we're looking at, they can give you amazing feedback quickly. Tips for success. I think this is my last major slide. We want to create mutual value for the people that we're working with and for ourselves. If we're just consuming the web service, we're not going to get what we need necessarily in terms of support. So we want to come in, here's what we're working on, and this is how it's going to benefit you, but I still need to get my stuff done. The other thing is I schedule regular calls with them, weekly calls, bi-weekly calls, because I want to keep that developer evangelist on the hook. Send thank you notes and gifts. I use back-channel communication all the time. Twitter is a fantastic tool to get done what you want done because you follow them and then you just tweet things that you want. And eventually they will start calling you back. Push, but not too hard. I mean, that's the game here, right? As much as it is a technical play when you're dealing with web services, we're also dealing with a third party that's unknown. So we've got to treat them like we're high school, taking a girl out. Come on, I'm really awesome. Right? It's courting, right? It's the dating relationship. So push, but not too hard. Don't appear desperate. And then there's the last little bit. Anyway, if you got questions, I think that the slides will be up online. But if you have questions now, I'm happy to tackle them as well.
I have a question.
Yes, sir, with the awesome mustache.
I'm a front-end guy, I'm not a back-end guy, I'm not an API guy, but sometimes I have to do this work, integrating with Twitter and stuff. And
Right.
I don't want to ask questions to the right people sometimes because I feel like I probably wrote something really, really dumb in here, and it probably is my fault. And if I ask somebody, I have to show somebody this really crappy code, and they're going to be like, well, it's because it's terrible code. Like, when do you stop trying to solve it yourself and ask for help?
For me, the rule is about like 1 to 2 hours. I mean, honestly, like burning much more time than that, it's like, and I always start with, look, I suck. I'm a terrible programmer. Let's start with that. Can you help me? I'm sorry, I'm embarrassed to even show you this code because the stuff that comes out of your fingertips is made of gold. Right? And so, the people who are here with me, they're like, yeah, he talks like that all the time. All right, other questions? Look at that. I know you're ready to clap. Anyway, hit me up if you need me, and then there's me on Twitter as well. Thanks, guys.